In this video, we're going to be looking at similar triangles. If one shape is an enlargement of another, we say they are mathematically similar. This means that there is a common scale factor of enlargement between corresponding sides of each shape. So if we've got two triangles here, a small one and a big one, if you look at the corresponding sides and they've been coloured accordingly, you can see that in the big triangle, the sides are 3 times bigger than the small triangle. The small triangle has been enlarged by a scale factor of 3. These triangles are mathematically similar. So how can we use similarity to find unknown lengths in similar triangles? Well, first of all, we have to prove that the triangles are similar. To do that, we have to show that the angles are all the same. And if you look here, my angles in each triangle are the same. I've got an angle with no marking on it in each triangle, an angle with 1 marking, which indicates that they're the same size as each other, an angle with 2 markings, which indicate they're the same size as each other. So these two are similar triangles. So, first of all, we've got to identify similar sides. Now, if you look at the sides between those 2 points, those 2 angles, I'm going to shade them green. They're in the same place on each triangle. Then I can go from the 1 and 2 angle and shade them a different colour. So I'll shade them to be red. And then we've got from the blank angle to the double angle, and that one I'll make blue. And they are corresponding lines on each of the triangles. So the next thing we have to identify is 2 numbers which occur on both triangles on the same colour line. Here we've got the 2 and the 8. Using that information, we're able to work out what the scale factor of enlargement is going to be simply by dividing the 8 by the 2, the biggest number divided by the smallest number. So in this case, my scale factor of enlargement is going to be 4. This means that the big triangle is, every length in the big triangle is 4 times bigger than every length in the small triangle. Or every length in the small triangle, you divide the big triangle by 4. So we work both ways. To find the value of x, we compare the red lines. The big triangle is 4 times bigger than the little triangle, so x is 4 times 3.5. To find the value of y, we're going the other way. The small triangle is 1/4 of the size of the big one, so we do 12 divided by 4, which is 3. In this example, we can see that the triangles are similar because the angles are all the same. So we've got to identify the corresponding sides. So, using the angles to help us, between the 2 and the 1, I'm going to make it in red. Between the 1 angle and the blank, I'm going to make it green. And the other side, I'm going to make blue. So we've got to identify which corresponding sides that we know information on. So if you look at the red lines, we know that one of them is 24 and the other one is 8. So we've got 2 sides which we can work out our scale factor from. So our scale factor, remember, was the big value divided by the small one. So we've got the big triangles on the left this time, the small ones on the right. So we're going to have 24 divided by 8, which is 3. So there's my scale factor. That tells me to go from small to big, I times by 3, and to go the other way, I divide by 3. So, to find the value of x, we compare the green sides. Now we start with the big green, and we're going to the small green, so we're going to divide it by 3, so my x must be 6. And for the y value, this time it's 3 times bigger. So it's going to be the blue ones, so it's 7.5 multiplied by 3 because we're going from small to big this time. Example, you can see that the triangles are both similar because all the angles are the same. So let's find the corresponding sides and we'll colour them accordingly. So we're going to colour the corresponding sides, 1 pair red, 1 pair green and 1 pair blue. Now the next step is going to be to identify on which of the colours do we know both lengths. So if you look at the green ones, we've got a 10 and a 12. So from that we can work out what the scale factor enlargement is going to be. It's going to be 12 divided by 10. We could use 1.2, but actually sometimes it's easier to use a fraction. So let's just simplify that and let's use 6/5. That tells me to go from the small triangle to the big triangle, I multiply by 6/5. And to go from the big triangle to the small one, I divide by 6/5. Using this then to work out what the values of x and y are going to be. X is in the big triangle, So we're going to use, it's the red length, so it's going to be 14 multiplied by 6/5. Do it on your calculator, use the fraction button, and we get 16.8. Y is on the small triangle, so to get that one, it's the blue length, so we're going to do 13.2 divided by 6/5. And once again, use the calculator, and we get an answer of 11.